So today's topic is on reinforcement learning. So what is reinforcement learning? So the word reinforcement means that it is dynamic and it is environmental, subjective to environment. So how do you learn the environment? So it's the dynamic programming. So it depends on the environment. So let me go to the style of reinforcement learning. So the agent, which is the one that is so-called our smart guy, for example, it can be a chess player, it can be a taxi driver, etc. So the agent will take an action. So action means that you can take a next step in a chess, or you can just like driving towards the north, east, south, west. So at the end, you get either reward or punishment. So the reward will be positive points, and the punishment can be negative points. And this is the state you are in. For example, let's say today you are in a taxi driver. Say, for example, you are in Orchard Road. So your state is in Orchard Road. So your next step may be wanted to go to, say, for example, for those who are familiar with Singapore, you probably want to go to, say, for example, Bugis. So what is the next step you need to take? Say your ending point is Bugis. So of course you have to go towards the west and southwest. So if you go the other way, you go to northeast, then you are wrong. Sorry, you have to go to southeast. So if you go to northwest, then you're wrong. So this is an example. So if this is the ending +1, this is the ending -1. From start, you must move towards this direction, right? So this is the correct move from 1 1 1 2 1 3. So 1 1 1 2 1 3 3 2 3 3 3 4, right? So this is the one that you get, okay, and this is the one you get +1 point if you complete. So if you do the other way, you get -1 point, which is no good, which is here. If you go this way, it's -1 point. Then you go this +1 point. So it means that if you are at the start, so you move up is 80%, you move right is 10%, right? So you look at this. Now the biggest problem is that although you move right is 10%, doesn't mean that you don't take the move, because you may be able to find good things after you make the wrong step. Okay, so it's like genetic algorithm. You must brute force to try everything. So this is the perfect solution. So this is deterministic. But it also depends on each step you take. How much punishment you make. Usually every step will take some cost. So if you look at this, of course, towards 1, you're always moving towards 1. So you're always moving away towards -1. So if you look at this particular arrow, why it don't go up? Because it's close to -1, right? So you try to avoid. So actually this is a little bit wrong. But human is smart enough to know that you can go in this direction. But machine not necessarily, right? So this is if the step is -2, so every single step. So you rather go to get -1 to have less step than go towards away from -1, because every single step will take -2. So -1 become very insignificant. So if you look at every step is 0.01, so it looks more normal than the optimum. So if you look at -0.04, so you're not so worried about taking additional step, because each step the cost is very low. And -0.01, so you can see this -1 here, so you try to move away from it. And this is the plus. So when you plus, if you look at this box, it's actually keep going towards this box, so it can repeat, so you can accumulate many points. But you don't want the +1, because you try to accumulate more points. Do not reach this to destination, because each step is a plus. So something like this is a reinforcement learning. So Markov decision process, this is the one, and the taxi example. And shortly I will talk about this taxi example in the second video.